All right, let's take a look at this problem. Help with CALCULAUS. All right, so it looks like we've got a big integral here, and I'll admit this problem's a little tricky. It took me about 10 minutes just to solve it now on my own. Let's write it out, and I'll walk you through it step by step. Okay, so you look and you notice you've got a third degree polynomial in the numerator, a second degree polynomial in the denominator. You might be thinking, how am I going to do this? Am I going to break it up term by term and integrate each term? How would I do that? I don't see any like terms in the denominator and the denominator. How am I going to simplify this? And not only that, we've got a higher degree in the numerator than the denominator. So you might be thinking partial fraction decomposition. That might be a little tough here. What I'm going to say is the numerator is a higher degree than the denominator. Let's try just long form division. So we're going to divide our numerator by the denominator. So you might have done this before. We're looking at our first term here. How are we going to get 2x cubed? We're going to multiply our dividend by x. Then multiply x by 3x. Then by 2. And we're going to subtract out. Left with 0 here. We're left with minus 2x squared here. And there's lots of room to get stuff wrong in this problem, which makes it even more tricky. So now let's look at negative 2x squared. Well, what goes into that with 2x squared? That's just a minus 1. And now we are done with our division, but we're left with this remainder, which isn't so pleasant. So basically, we can rewrite this integral just to keep you up on what we've done here. We're left with this x minus 1 plus our remainder, which is 3x plus 1, over the same denominator, and all of that is getting integrated. And now we see that we have a first degree term in the numerator and a second degree in the denominator. So now you might be thinking partial fraction decomposition. And I would be thinking, yeah, that sounds good. So if we want to rewrite, let me just get some space over here. If we want to rewrite 3x plus 1 over this in a different way, we should factor that denominator. And just to save us some time, that is going to be the same as 2x plus 1 and x minus 2. And if you multiply that out, you'll get this as the denominator. I trust you know how to factor. Let's go on to the next page here. So just take what we had from over there, x minus 1 plus our 3x plus 1 over, and now that we factored it, 2x plus 1 x minus 2. So now we're going to do partial fraction decomposition. So to do that, we'll say 3x plus 1 over, and to save us some time, I'm going to call this here, I'm just going to call it d, our denominator. So this is going to equal a over 2x plus 1 plus b over x minus 2. So 3x plus 1 over d equals a times x minus 2 over 2x plus 1 times x minus 2. That's just our denominator. So d plus b times 2x plus 1 over a denominator. So now we say we have a coefficient of 3, and we have coefficients here of a and 2b. And we have a constant of 1. We have constants here of minus 2a and b. So now we have a system of two equations with two variables, so we should be able to solve. And once you do that, I'm just going to skip ahead and say that a equals 1/5 and b equals 7/5. So now that you've got these, you can plug them into here, and you're left with the integral x minus 1 plus 1 over 5 times 2x plus 1 plus 7 over 5 x minus 2. And you can just integrate that term by term, and that should be a much easier problem to do than the one that we were looking at originally. So I know that was a longer problem. If you've got any questions, just let me know in the comments, and I'll try to answer them as quickly as I can.